let's try another example of the Punnett squares. It says as a certain type of hamster, the color cinnamon C is dominant and the color white lowercase c is recessive. If both parents are capital C lowercase c, again that would be called a carrier, what is the probability that the offspring will be white? So let's make sure we understand this. Capital C, that's dominant. The dominant color here is cinnamon. So that would be a cinnamon colored hamster. We have capital C lowercase c. That is a carrier, but the carrier shows the dominant trait, so they would still be cinnamon. They would just be a carrier. So what would they need to be white? They would need two lowercase letters, which is the recessive. Those would be white. So let's consider this. It says both parents are capital C, lower c carriers. So here's a capital C and a lowercase c, a capital C and a lowercase c. Let's see what happens. I'd have capital, capital lower, and lower. So it seems to me that there is one that is dominant. The probability of that would be 1/4. There are two that are carriers, still cinnamon, but they're carriers. And there is one that is recessive, that is white. And it says, what is the probability that they'd be white? Well, the probability of being white is 1 of the 4 total possible. Okay, now we want to move on to the next concept, which is not probability, it's odds. Odds are very different than probability, but directly related. When you go to bet in Las Vegas, if you're betting on horses, if you're betting on any of the games, anything in the sports book, they don't use probabilities, they use odds. They use odds for payouts. If you did 12.3.0, we saw a little bit of odds when we did roulette. When we looked at roulette and we looked at how do they do the payouts, they did the payouts based on odds, not probabilities. They are very, very close to one another, so let's make sure you understand the difference. Let's go back to what the probability of an event is. To do the probability of an event E occurring, it is what you want over the total. The difference is when you do odds, the odds is what you want or wins over what you don't want, which would be losses. This would be odds in favor, except the way that we're going to write it is wins, and then we're going to do a colon, and we're going to do losses. So let's think about something. Let's take an easy event. How about the probability of rolling a 2 on a die? The probability of rolling a 2 on a die is 1 of the 6 sides. So there's 6 total sides that there can be. 1 of the 6 sides is a 2. So what would the odds be? Well, the odds is the number of times it occurs. It occurs once, and then instead of the total number of times, you do how many times does it not occur. So if there's 6 total times, and one time it does occur, 6 minus 1 would be 5. So the odds of rolling a 2 on a die are 1 to 5. That's how odds work. Notice, when you add the two numbers in the odds, the 1 and the 5, you're going to get the total number, which in this case is 6. Let's try it again. What about the probability of rolling how about a 12 when you sum the pips of 2 die? What's the probability of rolling a 12? Well, you need to think of that grid again. In that grid, when you had 1 to 6, and you added those numbers together, there were 36 total of them, and 12 was only one of those entries. So the probability of getting 12 was 1 out of 36 if you add the sum of the 2 dice. So what if this was a game and I told you you win if you roll a 12? Well, let's think about the odds in favor of rolling a 12. There would be one option of getting a 12, and then it's all the remaining, which would be 35. So the odds of rolling a 12 would be 1 to 35. So what I have shown you is called odds in favor. We could do odds against. Odds against are the exact same thing but backwards. There's 35 to 1 odds against getting a 12. If I said what's the probability against getting a 2, the probability would be 5 to 1. So anytime it's 4 probability or odds in favor, that would be what you want, which is wins to losses. Any times it's odds against, it would be losses to wins. So they're showing it over here again. Odds in favor is the number of favorable outcomes. What they're talking about here is the wins. Over the number of unfavorable outcomes, they're talking about the losses. Odds against, again, it would be the losses would be first, and then the wins would be second. So you just have to be able to understand that simple concept. It says when the odds of an event are written in fraction form, the fraction bar is read as the word 2. So odds of, when you see 3/2, you would read it as 3 to 2. So we can write odds 3 different ways. We could write it as a fraction, we could read it as 3 to 2, or you could also write it with the colon. The one that I prefer, which is the one that is used in the real world, would be 3 colon and then 2. So it says this form is also read as 3 to 2. So regardless of how you write it, you read it as 3 to 2. All right, so let's read the first example. It says if a pair of fair dice is rolled once, what are the odds in favor? Notice we're doing odds here. This is not a probability. It's not a fraction. So we have to write it as A to B. And it's odds in favor, so we want wins first and losses second, of rolling the sum of a 7. So again, we have to consider that chart where we had 1 through 6 on both of them. 1, 2, 3, 4, 5, 6. And we had to see how many number 7s we have. I've asked you several times already to write this on your note card to make it easier for you. But if you look, it seems to me that there's 7s on the diagonal. And we already did the probability of rolling a 7. So you should have seen that it was 6 of the 36 sides is rolling a 7. Well, now that we know the probability is 6 out of 36, we can do the odds. The odds, first of all, what I could do is just directly convert this number to odds. So that would be 6 times I would win. And then it's not 36 as the second number, it's all the rest of the times. So there's 36 total times minus the 6 would leave me with 30 times I would lose. The only problem with doing this is you need to make sure you simplify the answer. Both of these have a 6 in common. So if I do this, divide both sides by 6, I would have 1 to 5. So what's the probability of getting a sum of 7? The odds of getting a 7. The odds of getting a 7 are 1 to 5.